Now it's time to look into the fourth technique of data transformation, which is data encoding or simply encoding. So, before we understand what is encoding, let's look into why encoding is required. So the performance of a machine learning model not only depends on the model and the hyperparameters, but also on how we process and feed different types of variables to the model. Since most machine learning models only accept numeric variables, pre-processing the categorical variables become a necessary step. We need to convert these categorical variables to numbers such that the model is able to understand and extract valuable information. Okay, a typical data scientist spends 70 to 80 percentage of his time cleaning and preparing the data, and most of the data scientists may be newbies, so we'll be having a fascination that as soon as I become a data scientist, I will be working on the beautiful models and I will be creating wonders. No, not at all. That's not the reality. A typical data scientist spends 70 to 80 percentage of his time cleaning and preparing the data. Like a farmer, before he brings the crop, he has to prepare the land for the crop. Same for you too. The same applies to you. So a typical data scientist spends 70 to 80 percentage of his time cleaning and preparing the data, and converting categorical data is an unavoidable activity. It not only elevates the model quality but also helps in better feature engineering. Now the question is, how do we proceed? So which categorical data encoding method should we use? That if you want to understand that, we need to understand what is encoding first and then what is categorical data, and then based on the categorical type of categorical data, what all types of encodings we can do. So categorical data, we will look into what is a categorical data. Since we are going to be working on categorical variables specifically for this section, here is a quick refresher on the same with a couple of examples. So categorical variables are usually represented as a strings or categories and are finite in number. So there are three types of categorical variables. One is nominal data. So the categories do not have an inherent order. Example, the city where a person lives, Delhi, Mumbai, Bengaluru, Chennai. And the second one is ordinal data. The categories have an inherent order. The grades of a student, A plus, A, B plus, B, B minus. And the third type is binary data. It will have only two categories, such as male female. Of course, we can't say male female is a binary data these days, because in Europe and America they'll have 10 to 15 categories of gender. So it will become a nominal data. But yes or no, pass or fail, these are the perfect binary data. Okay, binary categorical data. So now, based on this example, and if you want to see another example for nominal data, the department of a person works in finance, human resources, IT, production, And if you want to see one more example for ordinal data, it's the highest degree a person has: high school, a diploma, a bachelor's, master's, PhD. So this is what in ordinal data, while encoding, one should retain the information regarding the order in which the category is provided. Like in the above example, the highest degree a person possesses gives a vital information about his qualification. The degree is an important feature to decide whether a person is suitable for a post or not. While encoding nominal data, we have to consider the presence or absence of a feature. In such a case, no notion of order is present. For example, the city a person lives in. For the data, it's important to retain where a person lives. So here we do not have any order or sequence. It's equal. It is equal if a person lives in Delhi or Bangalore. So for encoding categorical data, so we have a special Python package category package. We call it as Python encoders. Python, the package name is category encoders. Okay, so let's install this first before we get into the types of pip install category underscore encoders. So meanwhile, let it get installed. Let's get back to our work. So now let's look into the what is encoding. Then we will see the various types of encoding. So encoding refers to the process of converting categorical variable into numerical or binary representations that can be easily analyzed or modeled by machine learning algorithms or other data analysis techniques. So categorical variables are variables that represent discrete categories or groups such as color, gender, country, and cannot be directly used as inputs in most data analysis or machine learning algorithms, which typically requires numerical inputs. So the most important aspect is encoding is an important step in the data pre-processing stage, as it allows the analysis or modeling of categorical variables in a quantitative manner. I'm repeating again. So the pre-processing stage of data science project is very, very important. So encoding is an important step in the data pre-processing stage, as it allows the analysis or modeling of categorical variables in a quantitative manner. So there are several common types of encodings used in data science pre-processing, which are here that you can see on the screen. The first one is label encoding or ordinal encoding. Then we have one hot encoding. Then we have dummy encoding, effect encoding, then hash encoder. Then we also have the binary encoding that you can see here, and then target encoding. And in addition to that, we have base N encoding also. These are the encoders widely used in pre-processing of data, pre-processing stage in data science project. Now let's deep dive into the each and every encoding type.